Hai Assalamualaikum, we are from team OT5 and my name is Nur Melina binti Muhammad Nur.
Hi and Assalamualaikum. My name is Ni Arsha Balkis binti Ahmad Sirik.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Najimi bin Mak Fauzi. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Najmi. I will talk about the the hardware component that we use for this project. The first one is MikroTik router board. There are multiple reasons why we choose this board. The first one is its high performance networking. It was designed for advanced connectivity and wireless bridging. Second, it also supports dual band Wi-Fi support, which operate on both 2.4 and 5 GHz frequency. It was also flexible to set it up for various networking needs, and next, it was ideal for creating reliable wireless network. It's also suitable for extended distance, and 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 it was optimized for complex network setup. Second, we crafted antenna to provide network coverage for the MikroTik router board. The third component the third component is Cat6e cable. We use Cat6e cable because it was able to provide internet and power over internet, which is PoE, from the network switch to the MikroTik router board. We also can use it as a way to communicate to PC to setting up the setting up the MikroTik board using Winbox software. Next, for the software component, we utilize Winbox, a flexible program made especially for setting up and controlling all the MikroTik devices. For with with Winbox user-friendly graphical interface, we can quickly adjust different parameters to meet our unique needs. In this project, we use Winbox to configure and set up the MikroTik L23 board for our wireless bridging network. We were able to optimize the wireless connection performance and reliability by adjusting factors including frequency, bandwidth, security protocol, and routing thanks to its software in order to achieve a dependable and effective network for our project need. This procedure, which customizing the board, was essential. That's all for me. Thank you.
So I'm going to explain to you designation of antenna. So first of all, we are using printed Yagi Uda. What is Yagi Uda? Yagi Uda is a directional antenna commonly used for communication system. So it is known for its high gain and directivity. So below is concept for our antenna. So first of all, resonant frequency. The resonant frequency that we are using is 5 gigahertz, and we are also set up in a simulation. Second of all, the material. For the material is substrate. The type is FR4 and the thickness of this material is 1.6 mm. The thickness of the copper front and back is 0.0035 mm. So for the layout, there are three components that we are going to build in. So reflector, driving element, and 4 directors. The characteristic we have evaluated through simulation. We have firstly we set up 50 ohm in the simulation. This is because of SMA connected that has been connected through the antenna 50 ohm. So it needs to be same impedance or else it will be mismatched. If it's mismatched, the antenna becoming would work well. Second, the S parameter. From S parameter, we can see from the graph the resonant frequency as stated before, 5 gigahertz, and from that resonant frequency, we can see the reflection coefficient is negative 28.5 dB, which is good for our antenna because the minimum reflection coefficient for antenna is negative 10 dB, and we get negative 28.5 dB, which is good, so that the loss transmission less and 98 until 99.5% has been transmitted very well. And the VSWR approaches 1, which means the impedance match with the transmission line, which make the design of antenna is ideal. Lastly, we can see for far field, the gain is 9 dB isotropic. It also high gain and high directivity. This is the result for each characteristic through simulation. First of all, the resonant frequency 5 GHz. Second, impedance matching 50 ohm. Gain 9.3 dB. And lastly, 3D far field polar plot. That's all from me.
Hi and Assalamualaikum. My name is Nia Shabalkis binti Ahmad Siddiq. So I'm going to present my part, which is the casing antenna for my project IDP. So the first step, the first thing that I want to present was I was using Fusion 360 for the design, and I designed it in Fusion 360 before I fabrication it in the lab. So first step, I was doing the bodies part. If you can see here, the design was just a normal square, and then the diameter was in each diameter I was doing in each diameter was a 50 millimeter for the Bangkok part, and then for the x-axis the diameter was 120, and for y-axis the diameter was 140 millimeter. So the second part, I was doing the lid part, which is the upper part. As you can see, the cover part, I was the diameter was 124 and 0.492, and then the next one was 105.873. So that's all from me. Actually, I need to design more for the whole part, but I just wait until they give me the antenna and then the rotor board, so that I can fix it in my casing part. That's all from me. Thank you.